Welcome to MSN Digit Max. I am N. Manjula, Assistant Professor, Department of Mathematics, Madurai Sivakasi Nadars Pioneer Meenakshi Women's College, Puvandi. Here is a learning resource for Calculus Unit 1, Module 2. In this video, we are going to see about formation of equations involving derivatives and Leibniz formula. First we see formation of equations involving derivatives. We start with examples. First example, if xy equal to a e power x plus b e power minus x, then we have to prove x into d square y by dx square plus 2 into dy by dx minus xy equal to 0. So given xy equal to a e power x plus b e power minus x. Differentiate with respect to x. On differentiating left hand side, we arrive x into dy by dx plus y. Now we differentiate the right hand side, we get a e power x minus b e power minus x. Again differentiating with respect to x. So differentiating left hand side, we get x into d square y by dx square plus dy by dx plus dy by dx equal to a e power x plus b e power minus x. In the left hand side, we are getting 2 dy by dx terms. So adding, we get x into d square y by dx square plus 2 into dy by dx equal to a e power x plus b e power minus x. This equation can be written as xy. So we write x into d square y by dx square plus 2 into dy by dx minus xy equal to 0. Example 2. If y equal to sine of m sine inverse x, then we have to prove 1 minus x square y2 minus x y1 plus m square y equal to 0. Given y equal to sine of m sine inverse x, we take sine to the left side, then we get sine inverse y. So we write sine inverse y as m into sine inverse x. Now differentiate both sides with respect to x. We get, on differentiating sine inverse x, we get 1 by root of 1 minus x square. So in the left hand side, we are having sine inverse y. So differentiating with respect to x, we get 1 by root of 1 minus y square into dy by dx equal to m into 1 by root of 1 minus x square. Squaring on both sides, we get 1 by 1 minus y square into dy by dx whole square equal to m square by 1 minus x square. Then we cross multiply both the terms in the left hand side and right hand side. We arrive 1 minus x square dy by dx whole square equal to m square into 1 minus y square. Differentiating with respect to x, we arrive 1 minus x square into 2 into dy by dx into d square y by dx square plus dy by dx whole square into differentiation of 1 minus x square is minus 2x. That is equal to m square into minus 2y into dy by dx. Now cancelling 2 into dy by dx throughout. Since the term is common in all the terms, so we are cancelling 2 into dy by dx throughout. We get 1 minus x square d square y by dx square minus x into dy by dx is equal to minus m square y. Therefore, we arrive the answer as 1 minus x square d square y by dx square minus x into dy by dx plus m square y equal to 0. Example 3. If x is equal to sin theta, y equal to cos p theta, then prove that 1 minus x square y2 minus x y1 plus p square y equal to 0. Here we have given x and y. From this we have to find out dy by dx. So first we take x and y. X is sin theta, y is sin cos p theta. Now we have to differentiate these two terms x and y with respect to theta. Then we get dx by d theta equal to cos theta, dy by d theta equal to minus p sin p theta. From these two terms we get dy by dx. dy by dx can be written as dy by d theta divided by dx by d theta. So we write the corresponding answers, that is equal to minus p sin p theta by cos p theta. Now we write sin p theta value and cos theta value, that is given y equal to cos p theta. So we have to find out sin p theta. So we make use of the identity cos square theta plus sin square theta is 1. So sin square p theta can be written as 1 minus cos square p theta. This can be written as 1 minus y square. So sin p theta can be written as root of 1 minus y square. In the same way we can find the cos theta. Here we have given sin theta as x. So we make use of identity sin square plus cos square is 1. So sin square theta equal to 1 minus cos square theta, which is equal to 1 minus x square. So cos theta is root of 1 minus x square. So we substitute these two answers. We arrive dy by dx is minus p root of 1 minus y square by root of 1 minus x square. Now taking square on both sides, so we can cancel the square roots in the right hand side. So squaring on both sides we get dy by dx whole square equal to p square into 1 minus y square divided by 1 minus x square. On cross multiplying we arrive 1 minus x square dy by dx whole square equal to p square into 1 minus y square. Now differentiating with respect to x, we get 1 minus x square into 2 dy by dx into d square y by dx square minus 2x into dy by dx whole square equal to p square into minus 2y dy by dx. Here 2 into dy by dx is common in all the terms, so we cancel 2 into dy by dx throughout. We get 1 minus x square d square y by dx square minus x into dy by dx is equal to minus p square y. So equation can be written as 1 minus x square d square y by dx square minus x into dy by dx plus p square y equal to 0. Then example 4. If xy equal to ax square plus b by x, then we have to prove x square into d square y by dx square plus 2 into x dy by dx minus y equal to 0. So given xy equal to ax square plus b by x, differentiating x into dy by dx plus y equal to 2ax minus b by x square. Again we have to differentiate, then only we arrive the answer. So differentiating twice we get x into d square y by dx square plus dy by dx into 1 plus dy by dx is equal to 2a plus 2b by x cube. So simplifying we get x into d square y by dx square plus 2 into dy by dx equal to 2 into a plus b by x cube. Now we have to find the answer a plus b by x cube. So given xy equal to ax square plus b by x, we take x square outside. So we get x square into a plus b by x cube, which is equal to left hand side is xy. Now dividing by x square on both sides, we get xy by x square equal to a plus b by x cube. So we get y by x equal to a plus b by x cube. Therefore, we can write the equation as x into d square y by dx square plus 2 into dy by dx equal to 2y by x. Multiplying by x on both sides, we get x square into d square y by dx square plus 2x into dy by dx minus 2y equal to 0. So we take 2 outside, we arrive the given answer. Next example 5. If y equal to x plus root of 1 plus x square power m, then we have to prove 1 plus x square d square y by dx square plus x into dy by dx minus m square y equal to 0. So given y equal to x plus root of 1 plus x square power m, differentiating with respect to x, we get m into x plus root of 1 plus x square power m minus 1 into 1 plus 1 by 2 1 plus x square power minus 1 by 2 into 2x. And simplifying this term, we arrive m into x plus root of 1 plus x square power m divided by root of 1 plus x square. The numerator x plus root of 1 plus x square power m can be written as y. So dy by dx is equal to my by root of 1 plus x square. Taking square on both sides, we get dy by dx whole square equal to m square y square by 1 plus x square. And on cross multiplication, we get 1 plus x square dy by dx whole square equal to m square y square. Differentiating with respect to x, in this step, we get 1 plus x square into 2 dy by dx into d square y by dx square plus 2x dy by dx whole square equal to 2m square y dy by dx. Cancelling 2 into dy by dx on both sides, we get the answer as 1 plus x square d square y by dx square plus x into dy by dx minus m square y equal to 0. These are the problems given as exercises. So in the first problem, if y equal to ax cos mx, then we have to prove x square into d square y by dx square plus m square y equal to 2 into x dy by dx minus y. So here we have given y as ax cos mx. So we have to find dy by dx and then d square y by dx square. And on simplification, we will arrive this answer. In the second problem, it is given as y equal to e power minus x cos x. Then we have to prove d power 4y by dx power 4 plus 4y equal to 0. So we have to differentiate 4 times y, then we arrive the answer. The third problem, if y equal to x square cos x, then we have to prove x square d square y by dx square minus 4x dy by dx plus x square plus 6 into y equal to 0. So differentiate y twice, we arrive this answer. And then we move on to Leibniz formula for nth derivative of a product. So if u and v are functions of x, we differentiate uv as d by dx of uv equal to v du by dx plus u dv by dx. Again differentiating, we get d square of uv. In this step, we write this equation as d of v du plus d of u dv. So we arrive v d square u plus 2 du dv plus u d square v. So proceeding like this, we get d power n of uv equal to unv plus nc1 un minus 1 v1 plus nc2 un minus 2 v2 etc. u into vn. Using this Leibniz formula, we solve some of the problems. First one, find the nth differential coefficient of x square log x. Here we take u as log x and v as x square. Then only we apply Leibniz formula. So d power n of x square log x. This is same as d power n of uv. So d power n of x square log x equal to d power n of log x into x square plus nc1 d power n minus 1 of log x into d of x square plus nc2 d power n minus 2 of log x into d square of x square plus etc. All the other terms will be 0 since successive derivatives of x square after the second derivative will vanish. So we stop up to second derivative of x square. So totally we are having only 3 terms in the right hand side. So first we take d by dx of log x, that we know as 1 by x. Then d square by dx square of log x is minus 1 by x square. This can be written as minus 1 power 1 into 1 by x square. And then d cube of log x is minus 1, 2 by x cube is the answer. This can be written as minus 1 power 2 factorial by x cube. So proceeding like this, we write the nth term, nth derivative of log x as minus 1 power n minus 1 factorial by x power n. Similarly, n minus 1th derivative, n minus 2 derivative can also be written. So substituting all these values, we get d power n by dx power n of x square log x as minus 1 power n minus 1 factorial by x power n into x square plus nc1 minus 1 power n minus 2 factorial by x power n minus 1 into 2x plus n into n minus 1 by 2 minus 1 power n minus 3 factorial by x power n minus 2 into 2. So on simplifying, we arrive minus 1 power n minus 3 2 into n minus 3 factorial by x power n minus 2. And then example 2, if y equal to sin m sin inverse x, prove that 1 minus x square y2 minus xy1 plus m square y equal to 0 and 1 minus x square yn plus 2 minus 2n plus 1x yn plus 1 plus m square minus n square yn equal to 0. So this problem we already worked out in formation of equations using derivatives. So we know up to 1 minus x square y2 minus xy1 plus m square y equal to 0. So after that we have to take nth derivative for each term. So 1 minus x square nth derivative of y2 minus nth derivative of xy1 plus nth derivative of m square y equal to 0. So we write the nth derivative for all the terms. So 1 minus x square yn plus 2 minus 2nx yn plus 1 minus 2n into n minus 1 by 2 into yn minus x yn plus 1 minus nyn plus m square yn equal to 0. On simplifying, we get 1 minus x square yn plus 2 minus 2n plus 1x yn plus 1 plus m square minus n square yn equal to 0. The third example, we have to find out the nth differential coefficient of x e power x. Here we have to take u as e power x, v as x. So nth derivative of x e power x equal to nth derivative of e power x into x plus nc1 n minus 1 derivative of e power x into d of x. So successive derivatives of x will be 0. So we have to stop up to this term. So the answer will be e power x into x plus n into e power x into 1. So the e power x is common, we take outside, so e power x into x plus n. In the fourth example, we have to find the nth differential coefficient of x square e power 3x. So we take u as e power 3x and v as x square. Now we write nth derivative for x square e power 3x. That is equal to nth derivative of e power 3x into x square plus nc1 n minus 1 derivative of e power 3x into d of x square plus nc2 n minus 2 derivative of e power 3x into d square of x square. So on simplifying, we get e power 3x into 3 power n x square plus n 3 power n minus 1 into x plus n into n minus 1 3 power n minus 2 into 2. Thank you.